Hi guys, here we are looking at example 8 of our, I guess it's morphing into a game making tutorial of sorts. Or I'm not sure we'll just film everything, but rather we'll just kind of step in and overlook what's been added at certain points. Today though, I actually wanted to go back and look at something else I've been uh, tinkering away with. You might have heard this idea before, is that it's best to plan out your program first before you try and write it. At least have some general notes. So here I'm adding a separate file which we've called design docs. And in this file, it's just a complete, there's no code at all. It's just a commented section of code where I'm scratching down what things that each object in the game needs, how we'll do the mapping, and trying to get as much of this information at least written down so I can go back later on and work out how things are meant to interact. As I'm actually writing the program, you can go back and check things off. So let's have a quick overview of what I've been adding. So we're starting out with the player itself in the game, and hopefully I'll just put a reminder on screen about what game we're talking about. We're talking about Shamus here, and the Vic20 version in particular. So the player has certain animations that we need. We need a standing animation, we need a walking left, walking right, walking up and down. We don't have those at the moment, but we want to make sure we have some sort of record that we need these things. We might need a death animation as well. I don't know. What kind of movement does our player have? Well, he's allowed to move in 8 directions. So up, down, left, right. And he can move up and left, up and right, down and left, and down and right. Which mimics how the classic digital joysticks worked on old 8-bit systems. Okay, so our player can fire in all 8 directions that he can walk in. The exception is though, or the difference is though, is when you press fire in a direction, your movement stops. So you can't actually just run and gun. If I'm running left, I press the fire button, I stop while I'm firing, and once the button's released, he keeps running. But here we're just trying to lay out what things we need for our player. Then we to start looking at what kind of interactions and collisions we need for the player to react with its environment. First point here, we need collision with the walls and maps, and this is fatal. So when you run into a wall, it's like hitting an electric fence, a high voltage fence. The one exception is that in the Vic20 version, Shamus's hat is allowed to overlap the walls a little because it's a very low resolution and the gameplay area is quite low, so I think that's the reasoning why they allowed that bit of overlapping there. Our collisions with other objects, we have a list of characters here that we're going to, and what happens when we hit these objects. Now, I haven't defined what I mean by collision really. So a collision is any time that the pixels overlap of the 2 objects. We could use a region test there, just a general rectangular comparison. If the 2 rectangles overlap, then we do have an intersection. It's possible that the original version uses that, don't really know. But we'll try and do pixel for pixel collisions, which means that we need to add a feature to our library that can compare 2 sprites and then check if they overlap. We don't have that written as yet. It's just a specialized version of the drawing routine, really. So collisions, we need, if our player hits a spiral drone, they're dead. A snap jumper, dead. Robo droid, dead. And the Shamus, which is the kind of main character, dead as well. So if I hit the opposing bullets, then you're dead as well. But you're allowed to overlap your own bullets. So, which is kind of a game 101 thing, isn't it? For some reason, my bullets are impervious to me, but everyone else they kill. In real life, if it's my gun and I shoot myself, well, then my foot comes off. The other collisions that we need are to pick up items on the map. And in the game, we really have two main items. We have a key and a lock. And they're coloured pairs. So I think there's 3 keys and 3 locks. So like a red key and a lock pair and a blue one, or I don't actually remember the colours off the top of my head. So we need to be able to pick those up from the map, and the player needs to store those in its own inventory. So I made a note here that keys and locks will be part of the map. So we need to have a collision detection, not with just a sprite, but with a particular character that we're overlapping. Typical of these kind of games, or map-based games, that you might, if you think of Mario, for example, when Mario jumps up and hits certain pieces of brickwork, then it might reveal a secret. Okay, that's my little notes for what the player's about. We've got a player's bullet section. We need some animations for. He has different fire animations for when we're walking up or down, and left, right, again is different. Plus we need the 45-degree angles as well. In our intersections here, we need the player bullets. Yeah, so if your bullet impacts the walls, then it doesn't destroy the wall, but the bullet itself is destroyed. If the bullet leaves the screen through an open section, then the bullet is destroyed. Bullets don't detect impacts with alien bullets, so we can't shoot opposing bullets. Our bullets pass through theirs, and theirs pass through ours. And that's kind of a repeat of a previous point. Heading through here to our room or mapping system. These are all just kind of points that I've written down. They're not really, we're not going into really excruciatingly low detail, but we just want to have these things written down that we need these basic features. And once we have a list of the features we need, we can go back and implement any missing functionality into our engine in this case. So if we need certain kinds of collisions, we can make some code that does that kind of collision for us. This is the underground, dirty, down, hidden away, abstracted code that our game is using above it. So the game never does any low-level things. It just calls the predefined functions we've already created that do this particular functionality. So if we want to know if 2 sprites overlap, we just call, check sprite collision or something. We don't sit there and start comparing the bits for each individual sprite. That means the game itself is kind of abstracted from how the engine underneath works, which is a very common design. Pretty much everything works that way. You could argue that anyway. Anyway, so our mapping system here, what are we going to need for our room system? In the game, I think there are 30 rooms in the game, and you walk between rooms. There's no scrolling. So you start at one point and you work your way through to the exit. Some rooms have multiple exits, and when you leave a room, that links to another section, another room. So our game here I just made mentioned our game wheel is stored in a markup format containing all possible rooms. So this will be effectively a giant text file where each room is one block, and any sort of attributes that we need will all be declared within those blocks. So we can declare the whole game externally, and then all we do is just point the engine at the levels, and it should just be able to understand what it's meant to do all the way through. So a bit of messing around there with phrasing that material. But so what's next? Room screens include a list of wall. Okay, this is how we draw the basic layout of the room. So the rooms are going to be stored as a list of these horizontal and vertical line segments, which I've mentioned before, and we'll have some color stuff there as well. And here I've made a secondary note that so we'll have a default color for horizontal walls and a default color for vertical walls within this room. So every time we call, have a call for a horizontal wall, or it'll use the horizontal color that's been predefined for this room, and V wall will do the same for V color. Okay. Here we've got a secondary note that walls need collision response to all objects. In other words, we need a way of detecting if a sprite has hit the wall, and then depending on what the character is how we're going to respond from that collision. If the opposing characters hit the walls, they don't die. If any bullets hit the walls, then the bullet is destroyed. If we hit the ball, if the player hits the wall, then he's cactus. He gets killed. So this is one of those kind of weird kind of game ideas where the player and the opposing characters actually have different abilities. For some reason, we can't touch the walls because they're electrified, but the bad guys can happily touch them all they want. Pretty weird. Most games are like that, really. It's very unbalanced towards the player in general. Okay, so here we've got a comment that says room loader decodes the current room and renders the strip into system memory as a required character. So, we've talked about this before. Going back to this example in the actual test code at the moment, where we have a definition of something like this, H line, and would have a location and what wall fragment we're using. We might actually have blocks of this actually. We'll see how we go. Right, so each room has these kind of like a little script of actions that need to be done to draw the room out. We also need any entry and exit points as kind of hotspots. So when our character leaves a room, the engine knows what room we're walking into next. So it won't we aren't just walking from room 1 to 2 to 3 to 4, etc. We might leave room 1 and end up in room 10, because the layout of the map is quite a large area. Because some rooms have multiple exits. Okay. Right. So here, rooms will have invisible spawn points for characters. Spawn zones are where characters will appear within the zone. So the spawner might randomly generate a bunch of bad guys near this zone. This will need to be careful. What have I said there? We'll need to be careful about placement to avoid overlaps with map walls, and zones should not be too close to entry and exit points. So here what I'm saying is that to populate a room as you walk into it. Now in the game, what happens is that every time you enter a room, a whole list of opposing characters are randomly generated. Now the thinking is that we could have maybe 2 or 3 spawn points that are specifically located in the rooms. We randomly pick a number of bad guys that are in the room, and then we just assign them to being spawned from these certain locations, which is actually how my previous version of this game worked. I'd have to check that again now. I can't remember. Something like that anyway. The spawn points and these are invisible to the player. There's no visible representation of where this thing is on screen, but the characters are generated next to or very close to this point here. We can't put them all at the same location because all the bad guys will just be sitting on top of each other. So we want to move them randomly around a little bit, and maybe we use like polar coordinates or whatever. Just pick an angle from that point and a radius, let's say. So we might need a little mapping tool that lets us specify where the spawn points are, how big they are, or what sort of, maybe it's a rectangle or an oval shape or something, I don't know. And we just pick characters, just go randomly within that point, within that little zone. Hopefully that made sense. Okay, so what have we got there? So when we spawn characters, we need to be careful about where we put them. When we're leaving a room and returning, this is the same point. When leaving a room and returning, we'll respawn the room, so the player can go in and out to try and reduce the number of bad guys to battle. So if I enter a room and it's got 25 bad guys in it, which it won't have, we can just exit, go back, come back in. It may have 10 this time. So it doesn't remember what was in the room prior to it. Our rooms need to have our lock and key placements. So each lock and key are paired, as I said before, they're colour coded. These all need to be drawn as blocks to the map, so the player needs collisions with the blocks. No other characters can interact with the map actually. So aliens don't need to have any knowledge of key or locks, they just walk straight over the top of them. Here we've got picking up a lock adds to the player inventory. So rooms that have a pathway, rooms that have locked pathways could have script to clear override section when player has required key lock combo. Okay, so let's say you have a room that has a doorway leading out, but it's locked at this point. When we have both the key and lock pick up in here, we actually have a little list of things to do, and that what we could that list of things to do could be, or perhaps we have a render like let's say it's like a vertical wall. This represents that blocks the way out of a certain room that this key combination unlocks. We can also have, rather than having these absolute, draw a line here, draw a line there, we can have an optional one that's in our little level definition where when it goes to render the room again, it just goes, oh, okay, you now have both keys, so I'll render this particular section over the top, so clearing away any obstruction from the player's path. I hope that makes sense. I guess another way is you could just have a second copy of the room, one where the door exists and one where the door doesn't. I kind of like having a little scripting idea there. So when the player picks up those points, it activates this, and when the map is rendered again, or as the player is playing, that logic is taken into account. What else do we need? So we've got a mapping system. We've got our what we don't really have here is any conversation about these particular characters, do we? We've just got, well, we've got these characters, and we've named them out, which is they're named in the original game. We need more information about how these characters are going to move, how... I can't remember roughly how they do move. So we might have Grep Robo Droid. We have a section on, I'm going to move the mouse now, don't I? On the laptop again, it's a bit awkward where I'm sitting to do this. So, yeah, we just might have a little header, a little point here. And for animations, I think this particular character Robo Droid only has one animation. So in that case, it uses the same anim when moving in all directions. So it just keeps playing the same sequence of frames, even when standing still. Right, so this just gives us a little bit of a note that saying that it just plays the anim constantly, and it doesn't have a directional anim at all, just the same frames. Now we might want to have something about its movement, particularly its notes about its AI. Now, for memory, I think the three different character types in the game have kind of three different traits. The Spiral Drone is more aggressive and it tends to walk towards you. The Robo Droid is actually kind of the opposite of the Spiral Drone. It likes to walk away from you. So we'll put on the note here, it tends to walk away from player. To avoid, I guess, player's line of sight. We'll avoid player's bullets. For that, we need a bit more information. If we're going to try and make a character that is going to try and avoid a player's bullets, we need to have it look at, just probably run through the bullets and try and work out what's the best direction it can move with all of the current threats. And this is kind of how AI, or better AI, tends to work. I mean, calling this AI is really ridiculous, really. Behaviours. So imagine if we have our characters are standing here, and I'm standing over here, and I've shot three bullets in its general direction. If we just took the closest bullet and then worked and said, oh well, whatever direction this is coming here, we'll move it 90 degrees to it or something like that. We had a very, very standard behaviour. What we might do is we might actually go, well, maybe we get better results if we look at all of the incoming bullets and go, well, what's the best escape route to avoid them? If we're too good with that, in particular, it will be very difficult to play and very, very frustrating. So there's kind of a balance there where you've got to be somewhere in the middle. It's got to be somewhere that's a bit dumb and a bit smart. Same with the avoidance stuff here. With our character on screen, we're going to have, I think what we need as well is we need some way, we'll need to compute line of sight to player through the map. Through map. So if we can, when a character is first spawned, when the player is on screen, the temptation is going to be, we'll just move the character towards the player regardless. Now, given that there's obstacles in the road, we don't really know where these things are, we'll need to have something, maybe a one-step line of sight or two-step line of sight to try and find an appropriate direction for this character to move in. If it really can't reach the player from where it is, the temptation would be to, have some pathfinding, but in the original game there's no pathfinding, of course. They do tend to just kind of randomly move towards you, and they will pull up against walls and get stuck behind walls, but so that's okay if we have characters that do that, but we want to kind of, maybe if we have some line of sight, we can project rays towards the player. If that first level of ray hits the wall, we can look at the other 8 directions around from us and try and see if any of those give us a clearer path towards the target. If we step this out maybe twice, I guess, maybe once, twice, we might get something that resembles something that's a bit smarter, but it's not really taking that much effort to do. I guess the trick's going to be is when the character has no possible route to the player, what does it do? Does it pick a random direction to move in? Does it move away? Maybe it looks around its own characters and goes, well, I'm standing right on top of someone else, maybe I should move off that character there first. So we need to have a kind of a list of ideas. So here we'll need a computer line of sight map. So line of sight can be used to detect players visible if player visible and no bullets okay, so if the player is visible and there's no player bullets maybe within a certain radius of us, then we can move towards the target. Player isn't visible. We check alternate angles around us. for the nearest yeah, we can check other angles around us to see if another clear path. Yeah, it's a bit confusing what right there. We would have to revise that really to work out what's going on. So the general theory would be is that you would run line of sight from the alien to the player. And the line of sight really is just a ray intersection against the map. So this is another feature we need in our map stuff up here. Map system. Need function to compute line of sight between 2 points. Oops. Sorry, I just always in a hurry with stuff. Okay, so if our character can move in 8 different directions, so we can really just do 8 line of sight comparisons. Possibly try and work out then, go, okay, well, if you're, if you're at 90 degrees to us, we might well be moving in the down and right quadrant. If we shoot a ray out and if it intersects with a wall, we might go, okay, well, let's shoot a ray out to the left and then straight down and see if there's a wall intersection there. Now, it's not very smart, is it? But if that's not a possible thing, maybe we could just we shoot a ray towards the player. If the ray intersects the player or the player is very near that ray, that's good. That's our direction that we want to head in. That doesn't mean we're going to walk directly on that line. We might actually randomly vary off the path to try and make the character look a bit more like it's making weird decisions, like it's not that predictable in its behaviour. Because if they all just walk straight towards you, they're a lamb to slaughter. If our ray is cast towards the player, we might look at something and go, well, we can turn that around and do something like if the ray hits a wall, then that's when we could go, okay, let's back up a point and check the ray, check the direction that's 45 degrees on either side of that initial intersection point. Maybe that gets closer to the player without hitting a wall, that kind of thing. Not sure how this is going to work really, but we just try to wing it with working out roughly what we need this stuff to do, and because really this kind of behavioural stuff is that's going to make up a bulk of how this thing plays. The mechanics of that get it to work are quite simple. We just render this stuff, and we need some functions that do the actual ray intersection stuff, or whether it's line of sight or where it is. Hopefully you're following that ramble, because I am rambling. There's no. Anyway, the point I wanted to get to is that I haven't been doing nothing. I've just been sitting down with some time and just jotting down the things I think we need in this. I've written a couple of extra functions and plotted them into the graphics back end here. I think it's in this version. I'll just test that for now. I've got dot plotting, so you can plot a pixel plot pixels into the map. Of course, if you plot too many pixels, you run out of characters and the thing goes back. But like that. So you've got to be quite sparing about how many objects are on screen at once. But that's the drawing a dot is actually just part of the library. So in our game, if we need to draw maybe a few particles that when an object hits a wall or something like that, we can spawn them out. Which is something the original game didn't have, by the way. Right. Okay, so we hopefully have sort of giving you some ideas about how you can organise yourself a bit better, trying to tackle these bigger problems, trying to think through the problem before you get to trying to write it. And it doesn't matter if you try and think this thing through and you go, gee, this is just too hard or whatever. Then try and just cut it down to the smallest possible chunks you can. What kind of interactions do I need? What kind of, within that interaction, what do I need to make that occur? If I need an object to touch another sprite, to touch another object, what happens when they do overlap? I think an example I like a lot actually is if you've ever played Mario, or one of the many Mario games, there's lots of them. I think it's a turtle, isn't it? There's a turtle character. If you're running along and you run into the turtle character, you die. But if you're jumping and you land on top of the turtle character, then that kills the other character. Now, in terms of our game, this means we have two different behaviours when the same thing is occurring. Now, technically what's happening is two sprites are hitting each other, and we're determining what to do from different circumstances. So if I'm running along and I run into the turtle just head on, then I have a rule that goes, okay, I'm not jumping. I've touched the opposing character. That's a fatality. That's a death for my character. But if I'm jumping or falling and I touch a turtle, then that's, as long as it's on its back, I guess. If we determine it's on its back, then that's actually where we're destroying the opposition character. So just by trying to lay out what logics we need, what sort of things we need for our interactions can really help us up front when we go and try and write this thing. Without that stuff, it's often very difficult, and most of us like to write things off the seat of our pants, and they look like that. I'll be honest. I mean, this thing here I wrote, didn't think twice about it, just wrote it. But that's okay for the library aspect, where I've thought about this stuff a reasonable amount now, and we do. It's kind of been refreshed a few times already, as you can see by the various revisions I've published. But that's all right for the we'll call this like the lowest layer, the rendering code that's underneath this whole thing. If you think of it like a big stack, you've got at the bottom we have our low level code. This is low level code down here. That's all the nitty gritty stuff, all the stuff that does things like loading our image stuff, loading our maps, doing all the rendering our graphics. And then above that, we sort of have our game. Now the idea of this kind of abstraction thing, you probably heard this in different programming contexts, is that we design our low-level code and we don't really access the data that this code is managing directly. We just call from the higher level code here, from the game code itself, we just call our interface, our functions that do stuff for us. In this case, we've got functions that draw a sprite on the screen, or functions that load a sprite. So our game code doesn't need to know how to load a sprite or how to draw a sprite. We just have to determine things like how the sprite is moving around the screen, who's controlling it, collisions and those kind of things there. Even for collisions, we're just calling a function that's provided to us by this low-level code. So a game code is really just all about how things move, how things interact, without any of the lower-level stuff. And that's what PB really is. PB is you kind of doing your program, whether it's a game or application, doesn't matter. And the really horrible stuff is all built in underneath. Okie dokie, ramble on for too long with that stuff. I hope it wasn't too boring for you. I hope it gives you a bit of an idea of maybe some of the kind of planning that you need for your own projects. Certainly, this is not a massive design document. For me, this is kind of like a point list, things I've got to do. If you wanted to make a game with 10 other people, they would need to be very fastidious about everything about here I've just written animations, but what does the character look like? What color is the character? How big is the character? How many pixels, because at the end of the day, you've got to be so descriptive that when you pass that description on to someone else, they understand empirically what that means. If you go, well, I want a character with a big mouth and go left and right, and the art guy draws you a bunch of Pac-Man, Pac-Man sprites. Go, no, that's not what I wanted. I wanted something that looks like a shark or something. That should be in your documentation so everyone knows what we're doing. Ideally, have a sketch or something like that as well. I've mentioned this before, but one of the best things I ever did in my Amiga days was simply keep a bunch of pads, a bunch of these, A4 pads beside my computer. And the main projects I was working on, I would just sketch into them. Have screen layouts, general ideas, and keep notes beside them. And it's amazing how much easier that can be than trying to do this stuff on a computer at all. I guess today we have lots of visualization tools, but a pen and paper is not that difficult, and you can show it to your friends or whatever, and they can give you some direct feedback without it's right there and then. Anyway, sorry for going on so long. Thanks for listening, and we'll see you next time. We'll get stuck into hopefully finishing up the bottom end of this and then building our game. See ya. Bye.